Going into aphantasia, it's really neat. We are constantly talking about ourselves, society, our environment, how we think about things. Something that really distinguishes us as a leadership team instead of the other companies, the other leadership teams we worked on, is we're really trying to understand the difference between nerd and normal person, really. So one of our coworkers, Mr. Jay Carnahan, brought up this idea of, can you visualize an apple? And so I don't know if you guys have seen it online, but there's a picture 1 to 5. 1 just shows blank. 5 is a full 3D rendering of an apple. And the question is, when you try to visualize an apple, how does it look in your mind? What was shocking to us is that not everybody has this full 3D apple rendering. Like when I visualize an apple, I see it in my head, I can turn it around. I make up details about it. It's a full, like I could bite it in my mind. Whereas other people just see like the words, I guess, an apple. I'm not really sure. Have you guys heard of this?
Yeah, I heard of this. And I'm the same way. I can make the apple like whatever color that I want. I can see myself eating it. So I can't really comprehend like kind of the other side of the spectrum, I guess.
Well, and that's really it. The words the spectrum really applies. Like the differences in thought and understanding of what an apple is, the taste, or just the concept. I see an apple. Like I watch these YouTubers, and one guy, he does these magnificent 3D renderings of furniture that he's going to build, and his comment on the YouTube channel is, I do these 3D renderings because I can't visualize it in my head before I build it. So that's why I do wonderful designs and products for you guys to purchase. So I thought that was a neat little fun fact, tidbit of the idea of aphantasia versus hyperphantasia. And if I'm pronouncing it wrong, please let me know, subscribe in the comments below. Don't forget to hit the notification bell.
Ding. I'm Alex Fortin. I'm CTO at Cohesion Technology, and I am with
Derek Mathewson, Director of Product at Cohesion.
And
Craig Bergman, Solutions Architect at Cohesion.
And this is the Nerd Out Podcast.
For all you new listeners, the Nerd Out Podcast is where the three of us get to share some of the fantastic stuff we're working on, our perspective on nerd technology or high-tech news, and just provide an opportunity to share and comment about nerd topics that are interesting to our audience.
What do we got on the docket today?
I'm glad you asked. Thank you, Derek.
You're welcome. That's what I'm here for.
We are talking about data governance today. So a couple months ago, or maybe close to a year ago, Alex started a data governance initiative through Cohesion, and it's been a year-ish. So we just kind of want to talk about what we're doing, why we're doing it, and how we're looking at our data quality. Before we begin nerding out today, just want to do a quick shout out to the co-sponsor of Houston Poker Night with Cohesion Technology, Flecha Azul. Reach out to Lee Payne if you want to attend or if you want to learn more about both companies.
Our producers wants us to talk about the U.S. presidential debate and how it relates to the importance of data, and I don't know that we want to do that.
Actually, that was my idea.
Yeah. Oh, that was your idea.
Yeah. Well, we keep talking about
keep it on the light side.
That's easy, and we're definitely not going to get interaction with our audience. But the idea is data governance, like bringing it back to what we're talking about. The concept of fact checking, the appropriateness. Like we see clear displays of accuracy, congruence, cohesion, with all the fact checking that's going on, timeliness. Somebody makes a claim or a statement, and how soon from that statement is it validated or actually not. The news article that I saw this time was, for the first time, fact checking was happening live in the debate instead of afterwards with some type of fact checking score. I'm not sure that was a pro in this case, but it was really interesting from a data governance perspective.
Was it accurate though?
I'm not gonna
no comment on there.
No comment.
I can think of a lot of politicians making a lot of non-cohesive argument all the time, right? It's like, we're going to ban fracking and keep energy costs down. Like that would be kind of an incohesive, anyway, in the current world that reality we live in.
Mm-hmm. Yeah, it is interesting, talking about the idea of banning fracking. I know that's come up a lot with Kamala, and I was seeing something that was saying I think 95% 6% of our wells are fracked at this point through completions.
Yeah.
And so, and when we looked at, the recent data, looking at, I think we could probably share this too, like this from the government of Canada, and they're showing Canada and US wells drilled in oil and gas production. We can see how much more we're producing in 2020 versus like the early 2000s per wells. And you can see even the vertical wells is, there's a small number, but pretty well non-existent at this point.
Yeah, like it is literally the whole energy independence of North America is baked in like the fracking industry is kind of what it is.
Can we get an accuracy check on that one?
Government of Canada.
No, I understand that. I get it. That's good.
No, I think that speaks a lot to it, right? Because if 95% of our wells are fracked, and we look at most of our oil comes from these oil wells. We have the oil sands here in Canada as well. Yeah. But within the U.S., like one of the largest oil providers in globally, as well as Canada, and most of our oil production, energy production is coming from this frack technology.
Well, and actually we need both.
True.
Right? We get, all the refineries in North America, all kind of like in the middle range between the sweet and sour, like the shale oil is very, very sweet, and then we get the very, very sour stuff from either Alberta or Venezuela, but I heard that's a little more difficult nowadays.
Yeah, that's a little less fun.
So we need both, and that's kind of the mix that we have right now with our refineries in North America that makes us independent from whatever happens in the Middle East, because who knows what that is in the next 10 years.
Wicked. What's next on the docket, Derek?
I think it's a good time to jump into our white paper and discuss why we wanted to write this white paper and what we want to talk about today.
Perfect, Alex.
Yeah, I can take that. So yeah, like Craig mentioned, we started to really kind of put more of a framework around our data governance a little over a year ago. We've developed a lot of things in our stack, but also like we've learned a lot about how we need to think about our data, right, over the last year when as we've been developing some of the tools that our team is using here at Cohort to maintain our data quality to the highest standard. And it kind of drove us to write just this white paper that like really kind of like is a very condensed or as condensed as possible, I guess, Craig, version of like how we're thinking about that data framework that we've kind of developed in house. And so yeah, that's kind of what, and I think for anyone interested in the white paper, I think our marketing team is going to be making that available on our website momentarily.
Yeah, and just to bring this kind of back, so 5-6 years ago, the way we were looking at data is we just report the news, we don't create it. So we would have third-party companies send us their data, we'd take their data, we'd publish it, and we'd just show a straight-through path. So then the next question is, are we actually getting the data? And how much are we getting? How little are we getting? Where are we having lapses on? And what is the relative data quality? If our client sees a spike on one of the data channels, even though we're receiving it from a third-party company and we're just transmitting it straight through, they look to us and they say, well, how come the data quality is poor for this one example? So we started asking the question, what can we do to fix or create, like provide full transparency, provide the straight through for the fast data, but also have a different swim lane that we can have a filtered or a quality controlled data and start evaluating the quality.
Yeah, and something I think we could bring attention to, right, that I think we talked about on the first podcast is looking at like us being the data aggregator and passing that data through to the operator. I think having that realization of like some of these data quality issues, they're very hard to fix much later after the fact or post-analysis. They're not really possible for the operator or for any of our clients to fix once that data passes through us. So I think we see it as kind of saw it as we have an opportunity here. We can improve the data quality within the, for our clients and as well as within the industry.
That's right. Create a little value add. Yeah. So Alex started a framework or started us down this path, and we found documentation to support it on data governance. Alex, can you tell us about the kingdoms and dimensions?
Sure. So the data, there's a million ways in which to think about it, or at least we kind of boil it down to a certain set of characteristic that our data has that is relevant to its data quality. And so in every time you look at those dimensions, you also have to, we call them the kingdoms, but I think what's the proper word again that we found maybe better than kingdoms?
The kingdoms.
Kingdoms, funny.
We're
Okay.
stuck there.
So, for example, like Colbor, like we do a lot of time series, right? Because all frac and completions operations, there's a lot of time series data that comes through, but we also do a lot of contextualization. So the contextual data, aka the time log data, it's its own kind of data set, or would be its own kingdom. Same for the stage summary data, that's its own data set as well. And so when we talk about the dimension of the data, you need to think about it as a like per kingdom basis, essentially. Like each of those data types, let's say time series, the completeness or accuracy of a time series data is going to have a different way to be measured than for our stage summaries and stuff like that, obviously.
Absolutely. So every kingdom has a different method of measuring completeness, timeliness, etc. And I'm sure Alex will go through the 8 dimensions shortly.
Is that now?
It could be now.
Which one did you do recently?
Well, the one that we're looking at right now is cohesion.
Okay, well, not that one.
No, it's the third C, and I never remember the third C. Conformity. Yeah, that's right. This is the joy of working with a nerd. We got to look it up. We can't just let it go.
Yeah. So conformity is less important in the sense that I think, if you're running WitsML, for example, this is where your conformity comes in. Like you want to make sure that you're abiding by the standard of the schema of the data, the data structure.
That's right.
Right. So I mean that's less kind of top of mind all the time. I mean that's one of the easier one actually of the bunch. So
there's a lot of overlap though. Like the kicker is we have 8, 7, or 6 data dimensions, but if you look at the differences between congruence and conformity or cohesion and accuracy, there's a bit of a Venn diagram overlap. The challenge on these data dimensions is when we have a unique problem that it only affects one specific metric. Have each metric have its own place to identify clearly where the problem's coming from is really the joy of these data dimensions.
like how Craig thinks that way, that it's a Venn diagram, and in my mind they're very distinct things. So,
Apples?
Yeah. Clearly different apples. Completeness, that's one of the dimensions. So that is pretty simple, is your data set complete? So when you have a time series data and you're getting 1 hertz, like 1 data point per second, that you should have 60 data point per minute. Like that's about as simple as it gets.
That's right. One of the examples of a failing completeness that we're watching for and fixing is when we start a stage, because we have multiple sources of data validate every conclusion we come to. So we have a well state, and then we get frac or wireline data, for example. Mm-hmm. Well, we start a stage because of our valve state, but are we actually receiving frac data at the start of the stage or wireline data at the start of the stage? It's common that wireline wouldn't turn on their logger until they're after 500 feet due to safety issues. That's a data completeness issue.
That's right. Second is accuracy. So accuracy, typically what we try to do with accuracy, I mean, obviously is the data is accurate. So how do you measure that? And a lot of time what we aim at doing is finding a third party data source that can give us a comparison between the data that we have and the data and the data we should have, right?
That's right. Like in this case, we have things like frac XML files, where we have our stage report and frac has their stage report. And the ideal for the customer is that these 2 stage reports agree. Mm-hmm. Another really good example of accuracy that our sonic system, surprisingly enough, helps to solve is we often hear balls away on the launcher when they're doing a ball drop stack frac. Our sonic system hears where the ball goes away. There's one instance in memory where we heard balls away. It was cold out. It took 1.5 minutes for the ball to actually leave the launcher from that. That's a case of our system invalidated the accuracy of the verbal instruction, balls away.
And even like back to the sonic system is like normally they would just go with pressure, right? And like we'd come in with our sonic or acoustics on top of pressure, right? And then you have two independent data source kind of like telling a story, and then like what we're doing is making sure that the pressure and the sound we're telling the same story.
That's right. That's exactly it. Or the sound adds complement to the pressure. That's
So on the completions, on the wireline plug and perf frac side of things, where we're seeing inaccurate data between what frac is sending us and what we're calculating, what are some of the cases that you've come across? Like why are we seeing that? How do we solve that?
well, if we're looking from frac to wireline association, as in using frac data to validate the accuracy of wireline data, an easy one actually would be in the stage report and in the XML file, we see like a max perf depth, or we see like a stage number, for example. We're always looking for machine ways to validate the information that's happening on location. Like if we don't have access to the radios, how do we know that they skipped a stage? How do we know that this happened? And then how can we train our machines to do it so it's just perfect all the time? So in this case, when frac says maximum plug depth or maximum perf depth, and we look at the max of the wireline curve, we can validate stage number. And that's an accuracy check.
All right. The third one is congruence. And so an easy way to think about that is it's congruence in the sense of geometry, right? So that is the shape of your data. And so that's looking at one single data, one datum or stream of data, and looking at the normal regular shape of that data. So that's really applies very well to time series data, because if you think at your wireline depth or your treating pressure, they have a characteristic kind of pattern that it follows, and that's what congruence looks for. So what we do with the congruence piece is that we're trying to use some machine learning models in combine that with the data that we've been kind of collecting over the past years, and be able to determine like what is the statistical factor of every piece of data that we get, and see if fuck, I'm butchering this.
That's all right. Alex, a really good example of congruence, actually going away from the data governance piece, is actually into a feature that our customers are asking for continuously, which is frac overlay. And so the ability to overlay one stage over a previous stage to see, and the people's eyes are basically doing a congruency check.
Yeah, that's exactly it. Like the shape of the data, right? That's why, each curves, right, had a certain pattern that it keeps repeating over and over again, right? And statistically, you can determine if that goes outside of like a couple of standard deviation of that pattern, and that's when you can kind of detect that you have a congruence problem.
That's right.
With your data stream.
Is there any examples in the data sets that we see of like where it's incongruent? That's something that we've checked?
So what you'd find, for example, is as we get a lot of comma separated values without labels out there, is if you start your frac and your data is 1 to 10, you get 10 channels, and for some reason someone decided that 3 and 4 is going to flip. Mm-hmm. Well, all of a sudden, like what your expectation of what the curve should look like is going to become like significantly different than what you're actually going to start getting, and this is when you can flag an incongruent violation essentially, and that kind of triggers our team to kind of get involved with a lot of times like getting with the guys that are running that data source and figure out like what changed, and then like everything that comes with how we can kind of fix the data that was already provided downstream to the operator or to whoever's the data consumer.
Or if they have in wireline, one of the symptoms is if your speed is inversed. So usually positive speed is running in hole, negative speed is pulling out of hole, but that's actually inverse to the reality of speed. So if that flag isn't set at the start of the run, if you compare today's job versus yesterday's job, you'll notice numerically it's incongruent against the previous wireline values.
Interesting. I'm always like reading through this. I always get congruence and cohesion flip-flops. I think let's jump to cohesion. And yeah, you can try and paint that picture very clear of like why is these different.
Yeah, but that's really pretty easy. congruence is about think about again an easy example to think about is really those time series. A congruence relates to a single data stream, right? Treating pressure, you're looking at the congruence of treating pressure against 5,000 previous treating pressure that you've seen, and you're trying to map it over it and figure out statistically if it resembles the 5,000 previous treating pressure you've seen or not. That's what congruence is. Cohesion involves more than one data stream in that case. So for example, between your treating pressure and your slurry rate, is that a good example?
That's a fine example.
Yeah. So between your treating pressure and your slurry rate, you'll have a correlation in how they move in tango or in tandem together, right? And if you get if you kind of violate that relationship, this is when you have a violation of the cohesion, right? Cohesion means multiple things move in similar direction at different ratio at any given time, and if you're violating that relationship, this is where you find a cohesion problem in your data set.
So in the wireline example, if we're seeing a negative wireline speed when we're doing run and hole, that'd be a cohesion then?
Yes, that would. Well, if you're comparing depth versus speed, that would be a cohesion failure.
Yeah.
Okay. I was thinking they're comparing speed to our time log, I guess, of what the actual operation is.
That's actually an accuracy failure.
Oh, okay.
Because that's an external authoritative data set. Our time log and wireline speed are unrelated to each other, even though they're summaries of each other. That's why it gets fun.
Yeah.
Yeah, and that's where it goes back to this data kingdom thing, right? Because the contextualization data, it's its own data set. The time series data is its own data set. So we don't really look at them in terms of those data dimension individually, except for when you look at accuracy. This is where we kind of pull out from other data sets that informs us about metadata of what you're looking at, essentially, right? In that case, the fact that the pad state is in wireline for that well is metadata that informs you that you should have movement on that wireline speed and depth, right?
Yeah, that makes sense. So accuracy is it only measured using multiple data sets? I guess there's no way to measure it without having an external thing.
It's always the challenge, right? How do you determine that your data is accurate if you have nothing else to compare it to? So sometimes it's possible, sometimes it's not, but most of the time, even between our own data set that we generate, we can kind of create those accuracy check that cross between the data kingdoms. But that's really unless do you have any other example that speaks to accuracy that doesn't have to do with an authoritative second source?
The actual definition of accuracy is comparing datum against its external authoritative. The fun part is the chicken and egg problem, the fallacy of logic of if we're using frac data to identify a time log and then we're using time log to validate the frac data, that's the circular logic that actually invalidates our data governance policy. So using valve data or pressure data externally collected from frac, like from pump down, for example, to validate the frac time log is an accuracy check. It's just the details of, are we checking it against something else? Are we checking it against itself? Or are we checking it against something that comes in the same data payload? That's really the essence of data governance at Cold War.
All right, timeliness. Timeliness is a lot to do with what we do. We pride ourselves that our timeliness is fairly high. So timeliness simply has to do with that you get the data in time that's fit for purpose, right? So think about if you have a team of people that are trying to run a remote operations center out of Houston or Calgary, and obviously getting that treating pressure or that pressure data in real time or close to real time is very important, because that data for calling a frac, for example, loses value at every kind of millisecond that goes by without you seeing it and being able to act on it, right? And so for those time sensitive purposes, the timeliness aspect of the data becomes really, really important. And so that's. Do you have another example, Craig? Maybe around timeliness and how it gets impacted?
Yeah, the most common discussion is around latency from source to result. But actually, when we're talking about data governance and putting data quality rules or filtration on top of a data set, like there'll be an inherent timeliness delay every process that we add to a data from collection to receipt. So we talk about a fast but fallacy, or a fast but flawed process versus a slower but cultured process. The slower but cultured has a timeliness error intrinsic to it.
Yeah, and that's an important like distinction, right? Because sometimes there's a bit of a push-pull between those dimensions, right? Because like if you want to run your congruence tests, your cohesion test, your accuracy checks across like a time series data set type, every single CPU cycle you put in between, that data coming in and getting out to the customer is a hit on timeliness.
That's right.
And so that's why we think a lot of times, like we talk about swim lanes, we think a lot about, okay, we can have this fast lane, left lane of like, this is the data from the field as it comes in, right? And we also have another swim lane or another lane that's more about like, this is the data for forever, right? And a lot of times like it buffs a little more time and it's a little lower on the timeliness scale, but we can give much higher guarantees to that data. And so if you think about storing that data for long-term analysis and stuff like that, you'd much rather look at your slow lane than your fast lane. But if you're trying to call a frac and timeliness is paramount, then you need to have access to that fast lane data as well.
The other thing that I think about is if we're looking at the contextualization layer, if you have an error, let's say you're bringing your car in out of the oil and gas industry into the car industry, auto industry. You bring your car into the mechanic, like the information on what's wrong with the car always comes later. In the oil and gas industry, we have these NPT, these non-productive time blocks. We're not going to stand there beside the guy who's trying to fix the pump asking, so what's happening now? And get that into our document. No, the fire's happening. They're going to put out the fire. And then within a reasonable time frame, we'll get that information into our report. That is necessity, or by necessity, a low timeliness score, but a high accuracy or a high cohesion score.
Yeah, that's a good segue to jump to, because I think it's not as big of an issue I think we've felt on the timeliness side as the reporting, but something we have seen with some of our clients, right, is that with our daily and shift reporting, the clients want to have these daily reports that go out to everybody internally with their organization. And usually it's just a change management, but that timeliness where they want to get all that data in before the 6 a.m. changeover happens, they want to have that report complete and sent out to everybody. So that timeliness, but in those cases, right, there's not as much like data quality issues. It's more of like I guess it is, but it was fixed through like change management more than it is through other tooling.
That's right. Well, and that is a good demonstration on acceptable versus non-acceptable timeliness. If you have a stage ending at 5:50 in the morning, you need a short timeliness on the report to make it. On the other hand, at midnight, not a lot of companies are being run at 1 a.m. How much sand did we pump in the last 4 months? Reports. And if they are, they don't care about yesterday's stages. They want the month as a total, et cetera. And they need good quality, high accuracy, et cetera data, not timely data in that case.
And the last one is precision. Precision is pretty simple. I mean, to me, precision is literally like the number of digits after the decimal.
Yeah. Well, and the example for this one is we had a client, and before we came out to their location, their comment was we had accountants with stopwatches. And their job was to keep the time record of what was happening on pad with literally a stopwatch versus, an OSR. And their job is to sign tickets, to make frac decisions, to also keep their daily report and their time log. Well, I'm not going to say they have a high precision on their time entries. This 15 minutes, this is what we did approximately. That's low precision data. We come in with our...
Is that low accuracy though?
Well, it's low everything. It's low many things. But I mean, they're not recording 15 minutes 0000, and it's rounded typically to the nearest minute or the nearest quarter hour.
That's rounded. That rounding is your precision
is
problem.
The precision
right?
problem.
Right?
That's right.
I think that's one of the first things we tried to solve, kind of the inception of Colbor, was solving that precision on the time resolution of the time log. And it maybe
Yeah.
we don't think about it that much because we've solved that one for quite a while now. And
Yeah,
so
that's
we're thinking
wrapped.
about other
It's
stuff.
just it's a
Yeah, I mean
non-issue.
the auto-generated time log from the valve position sensors and pressure transducers in each wellhead is kind of how it all started, right? And it fixed a lot of problems for customers, like new and old.
Yeah.
That's right. Hey, Derek, do you want to talk about this week's meme?
What is this week's meme? Oh, the pray versus pray. Let's pull it up. Yeah, this one was fun. So we were talking about what meme, comes into this talk about like cohesion, congruence, and data quality and things. And we saw this I think it's a British game show, this meme where they try and trick the kind of the game with the comedians is what word am I actually trying to spell? So why don't we play the clip and we can talk about it.
Your word is pray.
Can I get that in a sentence?
You ever see an antelope hiding from a lion in a church with its two front hooves together? You've just watched some pray.
Do I spell both?
Well, you're going to spell one.
One? Oh, one of them.
Yeah. So the challenge is
To spell the right one.
to spell the right one. It's designed to be irritating.
I think that's exactly what it feels like with our channel mapping sometimes, where it feels like it was designed to be irritating.
Yeah, well, like the challenge is we get, let's say, 200 channels, or we get a list from Frac. Hey, here's the channels we're about to give you. We plug in. I would like to say half, as great as half of the time, the list of channels and the actual digital channels we get, they don't match. So the question is, how do we get it right before we actually have a data quality impact to our customer? And so that's it, is spell the right version of pray before you fail the test.
Yeah, and I think that's where all of our data tools come in, right? Everything we were talking about today, why we want to have tools to check the accuracy, the cohesion, the congruence. All of us give us a hint at, did we spell pray right this
That's
time?
right. Did we answer the question right before it becomes financially impactful to our customers? Awesome. Well, thank you so much, everyone. This is Craig, Alex, Derek doing another Nerd Out with Cold Bore. Tell us in the comments, what's your favorite dimension? Did we miss one that you want to talk about? What are some other data quality issues that you have, and how can we help solve them? Once again, like, subscribe, follow us on Instagram, hit a thumbs up on LinkedIn if they do that, and watch our upcoming videos. Also, don't forget Cold Ones with Lee Payne, and that's us.
Data in hand, we rock the bytes and we'll take a stand. Calculators flashing like a disco ball. Cold board tech, hey, we answer the call.